And
hello.
Okay. So the next
Yes.
session, the subject is Axiomatizing Consciousness, Setting and Postulates. And to have the talk, we have with us a live video lecture, Professor Henk Barendregt, Radboud University, Nijmegen and the Netherlands. So before I start, I would like to tell you that any kind of queries, any kind of questions in your mind, you can do WhatsApp on this number, that is 8240-819460. If you want to question, if you want to drop any kind of question, you can drop in this WhatsApp number. Again, I want to announce 8240-819460 in this screen, you can see. And before I start, I would like to introduce Professor Henk Barendregt. Professor Henk occupies the chair of Foundations of Mathematics and Computer Science at Nijmegen University, the Netherlands. Since 1986, he is professor at Nijmegen University, where he and his group work on formal mathematics or technology based on the idea of automated verification of mathematics program of N.G. de Bruijn. Barendregt was elected member of the Academia Europea in 1992 and the Royal Dutch Academy of Sciences in 1997. In 2002, he was knighted in the Order van de Nederlandse Leeuw. Barendregt obtained on February 6, 2003, the NWO Sponsor Award 2002, the highest scientific award in the Netherlands. For some years, Mr. Barendregt has been studying consciousness. In 2012, he obtained the Distinguished Lawrence Fellowship, a joint prize by the Netherlands Institute of Advanced Studies and the Lawrence Center, Leiden, organizing a workshop on the models of consciousness and clinical implications. So, Professor Henk is on live video chat with you, and here is the lecture. Enjoy, and any kind of queries, any kind of question you want to ask, here is the number on the screen. You can ask him in the WhatsApp number. Thank you so much and enjoy his lecture. Thank you.
Good afternoon. I'd like to thank the organizers of the Bhaktivedanta Institute for inviting me to this conference on mathematics and reality. And as an important aspect of reality is how it comes to us, how we perceive it, I would like to speak about consciousness. Now, there is a problem with consciousness. When we try to imitate human beings, then we can think of a robot that can move and it has a camera and a microphone. But do we miss something? Well, it is not the intentions that humans can have or the emotions that humans can have that are the problem. What seems lacking is the awareness, consciousness in a robot. And we do not even know what it means that they would have consciousness. In the axiomatic method of Aristotle, we do not need to explain the primitive notions. We just use them. So I will use consciousness as a primitive notion. And the method is built up from relationships between several of the primitive notions, and that are postulated to hold axiomatically. And in this way, we try to give various approximations to consciousness. And we will describe several classes of agents in order to do this. An agent, A, lives in a world which is its environment. So the world W and A, they both have a state for each moment t in time. So we have W, t, and A, t. Then the world and the agent interact. So the world at moment t and the agent at moment t, here you see it, they interact and they create the world in the next moment and the agent in the next moment, somewhat changed. And this will take some time. And then the new states interact again and again. So here, axiomatically, we want to make time the discrete set of integers, z, the negative, 0, and positive numbers. We will describe 5 classes of agents. It's a hierarchy, and they will get more and more complexity. Starting with Turing machines, then robots, then agents with priorities. We can think of animals, then agents with cognition. We can think of higher animals, and then finally agents with mindfulness. And we can think of human beings. And class 5 is intended to approximate aspects of consciousness. Now first, the Turing machines. A Turing machine has an infinite tape of cells as its world, and they are numbered by the integers. Each cell may contain a 0 or a 1, and then there is a reading and writing head located on one of these cells. Depending on what the agent reads and what is its state, there are 3 actions performed. Writing a 0 or a 1, changing the state, and moving the head to the left, to the right, or neither of the two. And these actions can be written down in a fixed finite list of 5 tuples that is fixed for each Turing machine. The initial content of the tape represents the input, and if the machine stops, the final content, the output. Now, Alan Turing in 1937 showed, using introspection for the first item, that any computational job can be done by some Turing machine. However, there is a universal Turing machine, UM, that can imitate all the other Turing machines by extra input on the tape. And nowadays, everybody knows this. We need also software to run a computer, and that's the extra input. Then Turing showed that there is an unsolvable problem about the universal Turing machine. Does this machine with input X and extra input X, so the program, does that stop? That's the famous halting problem. And in this way, he showed that computers cannot solve all human problems, not even human problems about mathematics that are very clearly defined. Leibniz, when he was thinking about machines, he wanted to ask to the machine, does God exist? But this question is out of reach, and even mathematical questions are out of reach, as Turing showed. But the universal machine became the programmable computer. The next class of agents are robots. They have sensors and actuators connected to special parts of the memory. A simple example consists of a thermostat with a heater or an air conditioner switch to regulate the temperature in a room. More advanced robots are embodied and move around in the world. A simple example is one that vacuum cleans the floor and goes to the electric outlet if the battery is low. Such machines we have now. Now, once you are in the world is part of the memory. And when you mimic the Turing machine description, a robot originally would act as follows. You have an input, the I, and state, the S, and then you come into a new state and then a new action. And then because of the action, you're in a different place of the world, so you have new input, and you already had a new state. And this goes on and on. But now it's better because of the embodiment to write things as triples, input, state, and the action. And it gives the next input, the next state, and the next action. We do not want to wait till we see what we did, but from the doing itself, we calculate the next state and action. Now, in the next class of agents, the input is not a single bit or byte, but a large collection of these. Think of it for yourself. Not only you may be looking at screen, but you see other aspects of this room. And you hear my voice, but you also may hear other things. But then there is the mechanism of focus, of attention, that selects a subset of these. And this F selects a subset of all the things that are present to you, I1 till IN. All those inputs are there, but you select only some of them. And in the same way, you have several actions possible, so A1 till AM, but G selects a subset of them. And this is good to have, especially for us animals, because we can give priorities to some of the actions. You have decided to come to this conference, sit here and listen. Now, because of the complexity of the data, the transitions are no longer to be found in a finite table, because there is so much to react on. And now it is more efficient to implement a function f that calculates how to go to the next triple. So we have a certain input, a certain state, and already we have a certain action. We sit here and listen or speak respectively. And the function computes what to do next. And in MLs, this is computed by an artificial neural net. Interestingly, this introduces errors, discrepancies between the performed action and the agent's intention. But there are also other sources of errors, like the presence of other agents in the world. And what is a success of an animal? That means that it can reduce errors. Now, also agents in A3 will be given a rudimentary memory, notably associative memory. And this is given in the form of cued recall, something that has been studied already in early experimental psychology, namely in 1858, quite early. During the learning phase, input I1 is followed by I2, and we repeat this a couple of times. And then during recall phase, only E1 is I1, I mean, is presented, and the agent will then remember I2 and can react accordingly. For example, if earlier on the animal has learned that a certain sound means danger, then now from the sound only, the animal can start running away to safety. Acute recall has limited capacity, namely the number of pairs I1, I2 that can be stored, and limited reliability, namely the correctness of the remembered I2. We may sometimes remember it wrongly. In the next class of agents, there is cognition and learning. Now there is a new sense, namely the sense of the mind, that can contain symbols that may be given a meaning. And the meaning can be objects and actions, but also can be other symbols or other combinations of symbols. Why is the mind a sense? Well, if I mention the word Taj Mahal, that's a symbol, a representation of sound, then in your mind comes perhaps the picture of this beautiful building in India. So the mind indeed is an input and we can act accordingly. So how now can we obtain procedural learning? We can use repeated cued recall. The sequence of symbols then is remembered, like G1, G2, G3. And those symbols stand for put the stick shift of your car into gear 1, gear 2, gear 3, respectively. After some practice, one can drive a car, changing gears at the right speed. Also, cognitive learning is possible by dramatically enhancing the quality of associative memory, explained in next slide. This is the theorem by the Dutch mathematician De Bruijn. He says, suppose an agent has many units for associative memory, and all those units have limited capacity M and have reliability of, let's say, 50%. But we have a lot of them. Let's suppose that we have 10 to the power 10 billion of them. Then it's possible to construct a compound system for associative memory with capacity the square root n times m and reliability 1 minus e to the power minus 20, which is almost reliability of 100%. I will give you the proof sketch of this beautiful theorem. The 10 to the 10 small units of associative memory are made to be on or off at random, but in a special ratio. They are on for 1 moment, and then 10 to the power 4 moments they are off. So in real time, they are on for half a second, and then they are off for 4 hours. And this is energy efficient. Then by simple probability, because of the fact that we have 10 billion of those elements, at every moment, 10 to the power 6 units are on. During learning phase, these store the pair I1, I2, those 10 to the power 6. At recall time, which is later, there are also 10 to the power 6 on. But that's a different set. But now, of these million that were on during learning phase, and of those million that are on at recall phase, the intersection is 100 in the average. So they remember what I2 was, but not all correctly. And now they will give a majority vote among the 100 to the right association. And this is a way to remember large pieces of text with a high reliability. Now I come to mindfulness. In Pali this is sati, and in Sanskrit this is smrti, a quite important aspect of the human mind. And for the last 30 years, the practice of mindfulness has been very popular and successful in the West, but in India it has been popular already for several millennia. And I like to describe now what mindfulness is. Let's first look to so-called pre-consciousness in the agents up till A4. At every moment, they observe and they act and they have state. And this is denoted by a little rectangle. This is time, this line under here that proceeds discretely. You remember time was discrete. And here you see a snapshot of the world here and now. The next moment you see again a snapshot. It's a little bit better not to consider this as actual snapshots, but as elaborations and interpolations of what happened during this interval. You're not aware of that, but the next moment that your consciousness acts, you see an interpolation of what has happened. And in this way, you can explain the so-called five phenomenon of the Gestalt therapist, the Gestalt psychologist, or the Sperling experiment. You can find this in the references 29 and 23. In this way, you have your lifeline of configurations. And in your lifeline, you have the stream of what you see and hear, the stream of your state of mind, and the stream of your actions. But now, what is mindfulness? In mindfulness, you observe the previous mind state, which is still visible. And so here, not only you look in the world, but you look more closely to what was your previous state. And with attention now, you can choose not to engage in your previous state, and you become flexible. This will be explained in next slide. For example, at some moment, we see certain input I, and we have become angry because of the I. So here is our mind state of angriness. And when we are angry, we have unwholesome behavior. And that's the A prime. Now, mindfulness can transform this into the following. Rather than being angry, you see the angriness. So you use naming and you say, oh, there is angriness in me. But you say this, you state this in an equanimous way. And because of the equanimity, your actions can become wholesome. Better even than naming is noting. You do not need to use language to describe your angriness. You just observe, yes. And you feel your blood maybe boiling, etc., etc. But by observing this and by not allowing it in the mind state, you can change your behavior. So the art of mindfulness is to observe in an equanimous way our angriness. And in the same way, we can observe in an equanimous way our sadness or other emotions. And in this way, we can beyond our suffering. Because for the robots with awareness, there is suffering. I already indicated that there were errors when we act, and the errors form one cause of suffering. And I would like to distinguish between worldly suffering and existential suffering. Worldly suffering occurs when we do not succeed with our intentions, for example, by inaccuracy of our actions. Remember, we are programmed by neural nets and they only approximate, or by the impossibility of our goals, or by counteracts of others. And this goes on, and this, and this is the world of samsara. Existential suffering is even worse. With mindful insight into impermanence, namely everything changes, and the triplets of our state come and come and come just by themselves in a selfless way, following the laws of nature. Well, if we experience this for the first time, then we lose our balance. So that's the second form of suffering. Now, both types of suffering have as presupposition that the self is a permanent entity that is in control of what happens. But that's not the case. Now, mindfulness was the cause of suffering, but it also gives us a possibility of liberation, moksha in your language. So let's go back to the suffering. You have those triplets, I as A, the next one, I as prime, A prime, etc. And a particular aspect of suffering is that you loop. You become caught in a strange attractor and you cannot get out of it. If you could get out of your suffering, then it would be no longer suffering. So let's make a close-up. In this strange attractor, we see it here closed up. We have always changing input and actions. But now, using the invention of yoga, samadhi, concentration, we can restrict our input and our output. And that's what happens during meditation. We restrict our many possible inputs to just one, the meditation object. That can be your breath, it can be a kasina, a circle in front of you, can be many other things. But anyway, we fix our input. And in the same way, we do not act. We promise ourselves to sit still. So we obtain a projection of this strange attractor. The I and the A are no longer counted. And the only thing that changes is the state, S prime, S double prime, etc. And this is much simpler. If now we keep being mindful, aware, we obtain insight in the vicious circle with equanimity. And then when we surrender with determination, we can obtain a reset, a cessation, when the focus of our attention is just the empty set. we do not focus on anything, well, the input and actions are boring, so we do not need to see them. And when we have the empty set as focus, we observe emptiness that makes it able to make a reset of our conscious state, and we escape the strange attractor of suffering. So this is the end of my talk. Maybe I go to slide 1, or better this slide, by describing more and more rich agents, from Turing machine to robots that are already having a body. The Turing machine didn't have a body or didn't play a role. Then we come to A3 with priorities, A4 with cognition, and A5 with mindfulness. I think this gives a relatively accurate approximation of consciousness. And when we have the flexibility due to mindfulness, human beings are more able to have the act of compassion. If we do not see the situation clearly, then we are in ignorance, and compassion is difficult to perform. And I do not want to hold that this, to claim that this finds all the secrets of consciousness, but at least we have described now functional consciousness, including the consciousness that's needed for meditation, namely mindfulness. And we can explain suffering and its release by this model. Thank you for your attention. And maybe there are questions.
Thank you very much, sir. If anyone having any question, please do WhatsApp on that number, which is there on the screen. I hope you're gonna message as much as possible.
Yes. Okay. The question was how progress is made from A1 to A5. I see this as the progress of evolution. So, well, we do not start with the Turing machine, of course. We start as a simple animal, maybe a one-cellular animal. But already the one-cellular animal has priorities. If it finds poison in its neighborhood, it swims away. If it finds nutrition in its neighborhood, it swims towards the nutrition. And in this way, we have developed till more cellular animals, and cognition came there. And then finally, in human beings, mindfulness came that can look at our states, which is pretty similar to the, by the way, to the universal Turing machine. And that makes the universal Turing machine universal by being able to see its own states. Now, of course, we do not start as Turing machines, but from the description point of view, I started with Turing machines because they are the most simple agents to describe, and then the robots came, etc. But evolution starts from A3 till A5 as human beings.
So, gentlemen, if you are having any other question, then please WhatsApp as soon as possible. We got one more question, I guess.
Yes. Can you elaborate a bit more on self-awareness and qualia for A5? Well, let me start right away. I have no answer to the qualia. So that's still a mystery. But self-awareness can be explained in A5. Let me go to the model of mindfulness. So once we have mindfulness here at the bottom of page 13, we not only see the world, but we also see our previous mind state. So here there is some self-awareness. By the way, Brouwer says this possibility gives us the intuition of time, the famous Dutch intuitionist mathematician L.A.J. Brouwer. So self-awareness comes because we can see now our own states. And some people claim this will give us also qualia. I'm not so sure. And for me, qualia are still an open problem. Thank you for this question. Yes.
That is the last question of the session. Thank you.
There it is. How does a state of mind change without an input and an output? Well, let me go to the last slide. There is still input, but it is a fixed input. And it's the input of the meditation object. And there is a fixed output, namely to keep your posture of meditation. And then the physiological processes go on, and maybe after a little while we become impatient. And then we can observe the impatience, and then we can dissolve the impatience. So still a lot is happening, but the external input is stopped and the external output is stopped. And consciousness will develop by itself then. I'm done with this question. Yes, thank you for your question.
Thank you. Thank you very much, Professor Henk. And thank you very much, gentlemen, for putting the question right there on the main time. But now it's time to move ahead. And now would like to introduce to you all a new topic, and the topic name is...
One more, or...
Yes, we are done with that.
Okay.
Thank you so much.
Good afternoon, ladies and gentlemen. Nice to talk to you.
Thank you very much once again, Professor Henk.